Welcome everybody, you're watching Mr. Fugu Data Science. Today we will be doing basic natural language processing using RStudio for our online sales data project we're continuing. As always, the code will be linked in the description below. We will use QUANTEDA today for our NLP processing. The outcome will be separate some sentences into individual words, remove punctuation, stop words and numbers, generate word frequencies, do some plotting with word cloud and frequency graph. As of today, May 29th, 2020, inside RStudio, using anything less than 3.5, you will have issues installing QUANTEDA. I had 3.4 dot something. I had to update RStudio, I had to update R, and then I had to update all of my packages. Then, since we're using today Jupyter Notebook, I had to reinstall the IR kernel inside of RStudio so we could interface with Jupyter Notebook. If you need to update your Anaconda, I suggest you do that now. And choose the option of the developer tools install inside of RStudio again. Now, inside of Jupyter Notebook, I had to reinstall packages that I had before because I updated everything. I don't know why it didn't connect, but that's the case. So now I have version 4 instead of 3.4. Okay. We need to do our installs of QUANTEDA, Knitter, and Tidyverse. Then you do your libraries of Knitter, Tidyverse, and QUANTEDA as always, and then we'll get into the data. Since this is something we're progressing, I'm going to skip this, and then actually, let's do this. Let's refresh on what the data look like. Continuing from last time, what we did was remove any orders that had cancellations as well as the counterpart, which was the original order. This is the rest of the data that was generated where we got rid of that. Okay, well that's actually down here, but that's what the data will look like. So then since we're taking one specific column for the item descriptions, this is what some of them look like. You'll have a string of words for each item description. What we need to do is convert it to lowercase, where I use an lapply function. I took our column and called the specific of like method or function of setting it to lowercase. I stored that as product description lower, and what I needed to do from there was split our sentences into words. Okay, so then I do toString and then what we just converted to lowercase. Alright, then we need to create something called a token. Okay, where we're taking what we just split and we're removing all of the punctuation, the symbols, as well as numbers. And that's what that looks like here. Okay? From this, we generated quite a bit of words, but now we have to start moving on to frequencies. But in order to do that, we need to remove stop words. And a stop word is something like and, the, with, etc. Alright? So we remove those and we say token remove our stop words from the remove punctuation we created previous. And now you notice a difference. You don't have I, you don't have you don't have things like this. Now we're getting a little closer. But if you investigate these data and do your plotting, you'll notice something that you need to remove. And then you have to go backwards. So then I say, okay, now I need to do a remove of specific words. And that's what I called here. because I want to use something that's descriptive, that means something to me. While I could keep these and I could say, oh, people liked a lot of pink things, that doesn't help me out as much, so I'm removing those here. Okay? So then if you notice, we don't have the word color, the British word of color spelling here. We then have to create what's called a DFM, a document feature matrix, where we're taking our tokens and converting this to a matrix of document features. Okay? So what I do is I call DFM, and I take what I just called our tokens with remove stop words. And that's what we're generating here. And if you notice, you'll start seeing a frequency count of each one of these words. So we're getting closer, which is great. And if you notice, we have 2001 unique features. Okay, and each feature represents a specific word. Okay? Also, you notice that I don't have a sparse matrix here. The reason for that is I did not retain the space that was reserved for the word I removed. You can keep that and it would just represent a 0 in that space. But in this context, I neglected that because it just wasn't necessary, because I won't evaluate the words I removed for any analysis. Then we use a DFM select, where we're removing from our DFM based on some specific pattern. For instance, here, if you use the pattern of minimum n characters, that says that you're taking a word that has at least 5 characters in that word. You don't have to do this, but I'm just showing it because in some circumstances that may be needed. Here we're not using it, but it's an extra tool that you can use. So I need to say, let's look at our top features and let's get that frequency. And when I use top features and I say, well, let's look at the top 10 items by frequency. And that's what's printed out here. You can also select by a threshold value where you say, okay, let's get the minimum frequency based on anything that's at least 13. Okay? Then you could also consider, well, what if I wanted to do some grouping by words? And that's something we could look at later. You can look at, from the word you're evaluating, what other words are around that word in your sentence, like before or afterwards, right? You could look at things like that, depending on like if you were analyzing, let's say like tweets or something from the news, you know, that would come into handy. So we set up our word cloud plot, and it's really simple here. I looked for something that had at least a frequency of 13 or more. I put our DFM descriptions, and then I call the text plot underscore word cloud, and I set a random seed. And if you notice here, all these big ones right here occur the most. So it appears that in our online shopping data, people are looking for vintage things, bags, cakes, something that was related to the holidays, you know, so hearts and Christmas. Apparently people like retro items, you know, so this is really cool because it jumps out, it pops at you. It's really descriptive. You know, it's something like you plot and you can instantly see what's going on. Okay? You can also do a bar plot and make a little bit of a, let me get this a little smaller so we could see this. So, okay, so here what I wanted to look at was say, we're going to use the text stat frequency method or function that's within the QUANTEDA. And this allows me to take 20 of the top items by frequency here. So these are the top 20 items and their relative frequencies. You could input whatever you want, top 10, top 100, whatever you want. And then I'm using the dplyr method where I can call ggplot and I say, well, let's order this from highest to lowest, where the y-axis is the frequency, but we're flipping the coordinate system, so instead of these bars being vertical, they become horizontal, so it's a little easier for us to interpret. You just call this stat identity. And then your labels, you're taking everything for the X here, and then we're calling the top 20 here for our Y with our frequencies. And then I change the theme here so I can increase the size of our text so it can be legible, which is what we want. And I ran through this very quickly because this is something that you could pause the video, stop at home, work on this on your own, get an idea of what's going on, and plug in your data into these plots and figure out what's going on. It's very useful for an interpretation, for a project, for a presentation. I would like to say thank you for watching this video. Please subscribe and turn on that notification bell. Throw a like if you thought this was useful content. If not, leave me a comment and tell me why, so it could be beneficial for all of us. So I would like to make a better channel if possible. Have a good one. See you in the next video. Bye.